Okay, so today we're going to be talking about something called direct and inverse variation. It's pretty simple. It's not overly difficult, so we should be able to get through this relatively quickly. Okay? So, direct variation we're going to talk about first. Essentially what direct variation means is things being directly related, such as if you work at McDonald's and make $7 an hour, the more hours you work, what happens to your pay? The more you make. So the more hours you work, the more you make. Directly related. One goes up, the other goes up, right? Okay, so that's direct variation in a nutshell. So the formula that we wind up using for direct variation is y equals k times x. Does anybody recognize that formula? How about if it looked like this? Yeah, what is the m? Slope. Does the slope of a line change? It can, but then it's a different line, right? But generally speaking, if you're on a line, does the slope change? No. So in our case, we're using k. K stands for constant of variation. What does constant mean? Stays the same, doesn't change, okay? So our constant of variation, if we're talking in terms of you working at McDonald's making $7 an hour, our constant of variation is how much you make per hour. Does that change? No, not until you don't work at McDonald's anymore, right? So you're making $7 an hour. That doesn't change week to week. That's your constant. Make sense? Okay. So what that looks like graphically is just a straight line, which should make sense. If your x value is getting larger, what happens to your y value? It's getting larger because they're directly related. How about if your x value is getting smaller? And then your y value is getting smaller. Directly related. Does that make sense? Okay, so as I take and I shift that value of k, the line itself changes, but again, that's your constant. It doesn't change the fact that wherever you are on that line, your slope is the same. Agreed? Okay, so what does this actually mean in real life? We already talked about this. As the value of x and y increase, the value of x and y increase, everything increases. X increases, y increases, y increases, x increases. Good? All right, we're moving on from that then. So an example of direct variation is how much an hourly employee gets paid. His or her total paycheck is equal to a certain wage multiplied by the number of hours worked. We just got done talking about this, so let's try one out. In the equation P equals W times H, which letter represents the constant of variation? W. W stands for wage, right. So that's your constant variation. Your wage isn't changing. How much you bring in your paycheck is changing. How many hours you work is changing, but your wage is not. Good? W. All right, so I want you to rewrite this wage function given what this person is being paid per hour. So go ahead and do those two. That should be quick and easy. First one, what'd you get? Good. P equals $6.50 times H. Yep. What about the next one? P equals 9H. Any problems? Okay, direct variation is pretty simple. It's like distance equals rate times time, right? Same kind of idea. All right, so let's talk about inverse variation. Inverse variation is a little bit more difficult, involves two steps instead of just one. So two variables are indirectly related if their product of their values always remains the same. Essentially what it boils down to is you need to remember this formula, y equals k over x. K stands for constant of variation. Okay, so y equals k over x. So one of the key words that you will see, inversely related or inversely proportional. Okay, so inversely, that's your key word. As soon as you see that, you write down y equals k over x. The graph for something that is inversely related is a little bit different. It's actually a hyperbola. Okay? As x increases in this case, what happens to y? Decreases, right? It's inversely related. You just have to move your slider. Once you move your slider, guys, you'll see that. Okay? Okay? So as y increases, what happens to x? Decreases. So they're inversely related. They're opposite. Okay. All right, so we just talked about this. Okay, so An example of this in real life is when we have a salaried employee, like myself. I'm salaried. I earn a certain amount of money per year, okay? The amount that he or she earns per hour is inversely related to the number of hours she works. So think about it. If I make, let's say I make $40,000 a year, okay? If I work 30 hours a week, would I be making more hourly than if I worked 60 hours a week? Am I still making $40,000 at the end of the year? So would it make sense for me to work 30 hours a week or 60 hours a week? 30. Half the work for the same amount of money, right? Okay, so the more hours I put in during a week, the less my hourly pay actually is overall. Okay, so if you think about it, let's say I take home $1,000 every 2 weeks. Okay? $1,000 every 2 weeks I bring home. Let's say over a 2-week period I work 90 hours. What would my hourly rate be? Versus I bring home $1,000 every 2 weeks and I work 60 hours over those 2 weeks. What's my hourly pay? Go ahead, do that division for me. Let's see. 1,000 divided by 90 is going to give me what? 11.1. What about 1,000 divided by 60? I'm sorry? Okay, so which would be a better option for me? Yeah, I definitely want to work 60 hours, right? Never happens, but that would be nice. Okay? Good. So it's inversely related. Again, this is basically the same exact thing. I've got my weekly salary. I divide it by the number of hours I worked, figure out how much I actually earn per hour. So in the equation R equals S over H, which letter represents my constant variation? S, yeah. It doesn't matter what the variable is. It matters the position in which it fits in the formula. Okay? Okay, so I want you to go ahead and rewrite the rate function if the employee is being paid $900 a week, and then the next one for $650. Okay, what's the first one? Good, R equals 900 over H. Second one. Good. Problems? Pretty simple, right? Okay, so this is how we set up one of these problems. So what we're actually going to be working with is word problems, okay? So you have to know how to read the word problem and set it up. So go ahead and take out your note packet or your homework packet and open up to page 11. Okay, so let's look at the first one together. For a given set of rectangles, the length is inversely proportional to the width. Keyword? Inversely. Formula? Y equals K over X, right? In one of these rectangles, the length is 12 and the width is 6. So I'm going to write that down. Length is 12, width is 6. I always write down my known information. For this set of rectangles, calculate a width for a rectangle whose length is 9. So they're inversely proportional. I know my dimensions for my first rectangle. I need to figure out my width for my second. So here's your first step. We need to find K. We're not given K. We don't have a constant of variation. Okay, so we need to find it. So you start with what you know. Okay, instead of using Y and X, I'm going to use L and W, length and width. All right. I was given 12 and 6 for my first triangle, or rectangle, sorry. Why did I write W again? Sorry, there you go. How do I find K? Good, what is it? 72. Good. All right, so here's step 2. We've got our constant of variation now, right? I'm going to use that in my formula. What else do I have? You're looking for the next rectangle. I have the length. What don't I have? So we're going to find it. How do I do it? Yeah, cross multiply, which is 9W equals 72, or W equals 8. Okay, so the first step is to find the constant of variation given the information that they give you, using the information they give you. And then the second step is to use the constant of variation to find the missing piece. Okay? So let's try number 2. When air is pumped into an automobile tire, the pressure is inversely proportional to the volume. Keyword. If the pressure is 35 pounds, when the volume is 120 cubic inches, what is the pressure in pounds when the volume is 140 cubic inches? Okay. So how am I going to start? Use what I have. Good. So I'm going to set up what? P equals K over V. Yeah. So I have 35 equals K over 120. Good. Tell me what you get for K, please. $4,200. Okay. What do I do with that K? Okay, I'm going to use it. What else is known? The volume. And what am I looking for? Pressure. Tell me what you get. 30 what? Pounds. Use your units, please. Good. What do you think? Not bad. Okay, so I want you to go ahead and try number 3 on your own.